Chapter or section 3.1 example 3, applying integration by parts more than once. So we're going to do this two ways. We'll start with the way that we know to be true. So again, we're using our integration by parts. The integral of u dv is equal to u times v minus the integral of v du. So let's choose something that when we integrate it, it's going to disappear. When we differentiate, it's going to disappear. When we integrate, kind of just stays the same. So here we have u equal to x squared. And dv is going to be equal to the rest of it, e to the 3x dx. And now differentiating, we have du is equal to 2x dx. Integrating this, we have v is equal to e to the 3x times 1 over 3. And now we have the integral. So we have the integral of x squared e to the 3x dx is equal to u times v, x squared times 1 over 3 e to the 3x minus the integral of v du. Integral of v du is 1 over 3 e to the 3x. And du is 2x dx. Let's clean this up. 1 over 3 x squared e to the 3x. Minus, we could pull the 2/3 out to the front. And we have x e to the 3x dx. We have to apply integration by parts one more time here. So for this, we're going to let u equal x and dv equal e to the 3x. So derivative du is equal to dx. Integral, we have v is equal to 1 over 3 e to the 3x. So now let's rewrite everything else. We have 1 over 3 x squared e to the 3x minus 2 over 3. And then that integral is kind of the rest of it. So this integral is all the work here. Whatever we throw in there, we still have to multiply by that 2/3 because that 2/3 is being multiplied to this integral over here. So u times v e to the 3x minus the integral of v du, v and du. Let's clean that up one more time. E to the 3x. And let's multiply that 2/3 in. So that's negative 2 over 9 x e to the 3x minus and minus, that's plus 2 over 9 times the integral of e to the 3x dx. And lastly, we could integrate this part here. 1 over 3 x squared e to the 3x minus 2 over 9x e to the 3x plus 2 over 9 times 1 over 3 e to the 3x plus c. 1 over 3 x squared e to the 3x minus 2 over 9 x e to the 3x plus 2 over 27 e to the 3x plus c. And if you notice, we kind of did stuff that was a bit repetitive. So there is a bit of a shortcut. Let's see what that looks like. So what we had was the integral of x squared e to the 3x dx. And just as before, we choose a side to integrate and we choose a side to differentiate. So continuously we'll have the u side and we'll have the dv side. And from here, you choose your u just as you would. So here it's going to be our x squared. So that way when we differentiate, we start going lower. And over here is everything else. E to the 3x dx. So here we differentiate until we get to 0. So here, take the derivative is going to be 2x, take the derivative, it's going to be 2, and take the derivative, it's going to be 0. Over here, we integrate. Integrate, that's going to be 1 over 3 e to the 3x. And integrate that too. 1 over 9 e to the 3x. And lastly, 1 over 27 e to the 3x. From here, we go diagonal. So starting off with this times this times this times this. And because our integration by parts ends with uv minus the integral of v du, we need to multiply things by in an alternating fashion. So here it's going to be the positive, here it's going to be negative, here it's going to be positive. So this one's going to be plus, minus, and plus. So now let's throw everything together and see what we end up with. So the integral of x squared e to the 3x dx is equal to, starting off with these two here, 1/3 x squared e to the 3x. The next one is going to be this one, minus 2 over 9x e to the 3x. And lastly, we have this one, plus 2 over 27 e to the 3x, and plus c. And there we go. Let's see if they match. There's this one right here. So we have 1/3 x squared e to the x minus 2 over 9x e to the 3x plus 2 over 27 e to the 3x and plus c. There we go. So we could use this in these cases where we start going down in degree as we keep going. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.